on top of solving single linear equation, which was what we did here, solver has stronger functions than that. One common way of using solver is to solve system equations. So here I'm giving you a quick review on what that is. So system equations means multiple equations should hold simultaneously. And in order to solve it, we are looking for a combination of x and y, or a combination of variables that solves all equations. In order to have a definite answer of this solution, we require at least as many equations as there are for variables. Maybe you have heard 2 equations for 2 unknowns, 3 equations for 3 unknowns. That's what this means. We can solve them by hand by setting the equation equal to each other, by eliminating variables so that you have only one variable in one equation in order to solve it. Or we can use solver to take the best advantage of the calculating power of your computers. So this is the first way, which is a simpler version of solver. That is for questions like this, okay? There's 2 equations. If you were to solve them by hand, it's pretty straightforward. You just let those y equal to each other, namely the right-hand side of these 2 equations should equal. It's 100 minus 5x equal to 270 minus 3x, right? That's how you solve it by hand. And here solver actually follows exactly the same logic. What we do is to set equation 1 equal to equation 2, and we rearrange this to be equation 1 minus equation 2 equal to 0. Okay, and here we are going to use the function of setting the objective, which is the difference between these 2 equations, to a certain value, which is 0. Okay, and we added a variable cells. We add a constraint, which is not needed here. We're going to talk about this later, and eventually we hit solve. So this is the chat box of solver, right? We have the objective, which is the one that your goal is, and we are looking for a certain variable, then you set this cell to be that variable, okay? And if you are sure that your variable is positive, you can check this, otherwise uncheck this to make sure that you can find a solution, okay? Say if your result is negative, but you checked this, the solver will not give you a reasonable solution, okay? So let's look at this one example. Before getting that, if you are encountering problem, okay, there are several possibilities. One is you didn't follow this protocol, which is that you are required to solve each problem in the new worksheet, because solver utilizes the cache in your computer, and if you are solving multiple solver problems in one worksheet, the saved information is gonna confuse solver. Just don't do that. Or if you get an error saying there is no feasible solution, there are several possibilities. One means that the 2 lines do not intersect. The other is there is no solution for this system equations, or more likely, there could be mistakes in our entries. Just need to double check everything, okay? So let's look at this example. Here, in the first question, which is a review question, I'm recommending you to do this by yourself, which is to use solver to find the values that solve the root for each of the following linear equations. Actually, we did this in our slide 5. Okay, that's just a little bit review. And what we are to do here as a new thing is to solve the coordinate of the intersection point of these 2 lines. Okay, and here it is noted as example A of system equation. Okay, so here what we have is these two equations. I've copy and paste those here. Okay, what you have to do is to find an x that make these two equations holds, which means these two equations should be of the same value of y, right? So here what we can do is we calculate the difference in y's. Okay, so x is what you have to solve for, and y1 is 100 minus 5 times of x, and y2 is 270 minus 3 times of x. And the difference in y is y1 minus y2 or y2 minus y1. It doesn't matter. Okay, so here what are you doing? You're trying to have the x so that the value of y is equal to 0, namely the difference of y's is nothing. So that's what we are going to do. Solver. Okay, we are to solve, set the objective of your goal equals to 0 by changing the value of x. Here we don't know what the result is. Okay, we just uncheck this non-linear function restriction. So here it's minus 85. And looking at this, some of you may panic, or doesn't make sense, cannot make sense what it is. So you need to select format cells, change that into number. And here it's just a super small number. Okay, so this is how to do it. So let me demonstrate the other. How do you enter into mistake? So if you check this, make constraint variable non-negative, cell can only go to the value of x that makes the difference of y the smallest as possible, but it cannot entirely eliminate x because now eliminate differences in y's, because now you put the restriction on x to be non-negative, right? So if the solution is a negative number, you will not get the result. So what you need to do is to uncheck this. So as you are doing solver, always look at the result. You want to eliminate the difference in y, but now the difference is 170. That means previously you checked that restriction actually limits, prevents, conscribes you from getting the right answer. Right? So now as we uncheck it, we have this result. So as an extension, I would like to show you what the graph is like. So let's do from minus 100 to minus 90. And here y1 again is 100 minus 5 times of x. X is here. Okay. And y2 is 270 minus 3 times of x. All right. So now for x, we can just keep dragging down to, say, 70. Okay, let me make it smaller so that it's easier to do. So now for y1 and y2, if you want to apply the same rule for y1 and for y2 for each of their respective columns, what you can do is to select y1 and y2 and just drag them. And you can double check by double click. On y1, say it's 100 minus 5 times of the corresponding x. That's right. Let's just double check another. Y2 is 270 minus 3 times of the corresponding value of x. That's right. Okay. So now we have y1 and y2 and x. Now we can graph it. I just want to demonstrate to you how the graph is like. So let's just choose another cell that is irrelevant to any of those numbers, so that we can have a blank graph area to look at. Okay. And what we are going to do is select the data. Okay, so here you are to add the entry, the series name. So for the series, that's Y. Okay, and the series values, you need to select the value of the corresponding Y. So here we start with 1, 1. And this is what we have. Okay, so those are the value of Y's. The first one 600, the next one 550, the third one 500. That's right. But for X, it's not right, right? Here, it just gives you the count of X. The first X is corresponding Y is 600. The second X is corresponding Y is 550. We are not satisfied with this count. Instead, we want to make the value of X more accurate by changing the horizontal axis labels so that we can have the more accurate coordinate for each point. Minus 100, 600, that's the first one. Minus 90, 550, that's the second one. Okay, so here, as you are eyeballing this, you can find the coordinate, the x-intercept of the first line is 20, which is right. 1x equals to 20, 1, 1 equals to 0. Right? That is actually your first question. I'm just giving you a graphic illustration. So now that was only 1, 1. Now we need to look at Y2. Okay, just select the data again, and you can add legend entries. So now we are gonna add Y2 onto the same graph. Now I just need to select the value of Y2. See, Y2 is here in the orange line. Okay. And here we need to say show the legend so that you know which colors is corresponding to which line. Okay. So as you can see, Y2, the intersection point is even further down, say 80, 90, whatever, right? So those are the intersect, the x-intercept or the root for each line. But now if we are looking at the intersection point of both, we're looking at this, the point where both lines crosses each other, right? That's somewhere here. And we actually solved it. The result is minus 85, somewhere here, right in the middle between minus 80 and minus 90. So I'm using this to demonstrate. Also, I'm teaching you how to put multiple lines in one graph.